Hello everyone, welcome back to my channel, and today we are going to start a new series that is the data structures, and we are going to develop a lot of programs, and the language that we are going to use is the C programming. Now, why do we require a data structures and what exactly it is? So a data structure simply means how the data is stored and organized. So basically we are going to store the data, and now we are not referring to any kind of database related software. We are referring to the memory, and it is all about the memory management. It also means that how the data is retrieved. Data structure also helps in better memory management. So we need to come up day by day with better algorithms by which the memory management of the computer will be better, so that the system performs in a much faster way. So that is data structure. So it is somewhere kind of a system programming that we need to understand, and we are going to learn about it. So if you talk about C programming or C++, you might have worked with arrays. So array is also a kind of a data structures, because we are storing data in a particular format and organizing the data in a particular format. The problem with arrays are that it is assigned before the program execution, that is during the compile time. We need to declare an array, and then we need to give a size to the array, and then that many memory blocks gets assigned before the program execution. And if I'm just using maybe 10 blocks, and the size is 100, so 90 blocks are kind of waste. So that's not really a good memory management. So we need to come up with better solutions, and that's where we need to do some data structure programming. We need to come up with certain algorithms. Now the best solutions that for this is the singly linked list. Now many a times you might have heard about this. So we require a singly linked list for a better memory management, although every algorithm will have certain advantages and disadvantages. So we are going to start with this tutorial with a singly linked list, and we are going to use C programming. The platform that I am using, the IDE, is the code blocks. So let us begin. What we are going to do in singly linked list is we are going to assign a memory block, and this particular memory block will be having two parts. One is the data part, and the second will be the address part. And then we will accept data from the user. The data can be simply a number or string, anything. We will simply accept a number from the user and then store that into this data part. And then in the address part, we are going to store the address. Which address? The address of the next block. So for example, this is the memory block, and over here also the same memory block, the same structure, and the same thing I'm going to do is I'm going to store the data. Now understand that these two blocks will be connected with each other. And how are they connected? The address of this, that is 2457, I'm going to store this address in the previous block, and that is in the address part. Now over here by mistake it is 1026, but it should be 2457. So this memory address is going to get stored over here, and this is how these two blocks will be connected with each other. And when we say that we want to store a memory address, so definitely we require a pointer, and we're going to work with pointers a lot. So this is how we are going to store the data, and please understand these are not in the contiguous form. Maybe the address of this is 1024, and over here it might be 2457. So we're not storing it in a contiguous form, just like what we do in an array. Okay, so whichever block is empty, that block will get assigned, and that is how these things work. And then the same thing we are going to do with over here also, that is the address 7586. Again, this is just a small mistake. This address is going to get stored over here, and then the address that is 1028 will get stored in the previous block. And this is how the whole thing is working. Now it's looking perfect. So you can see that 2457 has got stored over here. So by using this address part, we are going to access the next memory block, and then using this particular address we are going to access the next memory block, and the same 1028, that's the address of the next memory block, and so on. Again, I repeat, this is not contiguous storage of data. This is like, shattered around, and these are just memory blocks that are shattered, fragments you can say, and these fragments are connected with each other with the help of the address, with the help of the pointer. Okay, and so we say that this particular memory block is pointing to this is pointing to this, and so on. So let us begin. Let us start with the programming, and as I said, I'm using a code block. So I'll just delete this part, everything, and we will do it from scratch. I will just keep the header files, and the header files are stdio.h, that's the standard IO header file. Then we have the standard library conio.h and malloc. This is the most important header file because for dynamic allocation of memory block we require this header file. Please understand it. So let's begin, and we will start with this particular block. We require this block of memory. Now this is going to have two parts, so definitely we require some user defined data type. So how we are going to do that? We are going to do that with the help of struct, and we will just give a name, that is nodes. We will have two parts to this, that is int data, and the second part will be like self-referring pointer, and that will be, that is struct node and a pointer, or you can name this as address. So this is like self-referring address variable. Okay, struct node star address, because we need to store the address of the next block into the previous block, so they need to be of the same type, understand it. So this particular thing which means is, this is a self-referring, that is pointer or the address, understand it. And then we need to give a semicolon, and this needs to be a pointer. Why a pointer? Because we need to store the address in this particular part. That's it. And then what we require is, we require some, now these are all global declaration that I'm doing, and let us just declare some variables, that is struct node, and again a pointer. I will declare it and name it as start. Now start will be the variable which will always point to the starting node or the starting block of memory, like these are the blocks. So start will always point to the first node, to the first memory block. Okay, so semicolon, okay, start and semicolon. Then we will start with the main program and the opening and closing braces. Then I'll just type the return 0, and from here then we will start the coding. We will declare the int n comma choice. These are the variables. I will give value to choice as 1. You can declare this as a character variable and give this as y and n. So the loop will go on till the point the user wants to enter the data. Now I'm assuming that those who are watching this video, the basic C programming is very much clear to you. So I will start with the while loop. I will say choice is equal to 1, which it will be because already we are assigned the value 1. So this condition goes true, and then we will say printf. I will say enter a number, and that number I am going to accept in the, I'm going to accept that is %d comma, that is address of n. So I'm going to store that in n. And then now let us just assign the value null to the pointer, that is start. Over here I will simply say if start is equal to null, then what we are going to do, this condition is going to go true, because this is going to tell me that this is the first time, the first node that is getting created. Over here we require one more variable, that is temp, and even this needs to be a pointer. Please understand this. Without pointer it is not going to work. Now I will say temp is equal to, let us just typecast, and now we are going to use that function, that is malloc. Now malloc is a function which will dynamically allocate a memory block. Dynamically means during the run time and not during the compile time. Malloc, and then we need to give a size of, that is the struct node. So that much size of memory block will be assigned. So this is just the typecasting that we need to do, and this is the memory block, the size that will get assigned. So now this will actually assign a memory block to temp, which means temp is going to point to that particular memory block, and then simply we will access the part, that is the data part. In that we are going to store the value n, and then temp of the address part, right now we are going to just keep that as null. So what is this going to do? This is going to have just one block, and for example the data is 10, so it is going to store 10, and this part it is going to store null. So this is where we are actually. If you talk about the picture presentation, we just have one memory block, and the data we will store it, and the address will be null. Then what we are going to do, let us give the semicolon. So this is the if part, and so we really need to do a very important part over here, that the start is equal to temp. This means that start is going to point to this particular memory location. So now start will always point to this particular block. So as I said, the start will point to the starting node of the linked list. So with this particular line we are going to achieve that. Now comes the else part. Now else part will take place when this condition goes false. Since now I am assigning, since now start is pointing to a memory block, next time this condition will go false. Then if it goes false, what we need to do is we need to have, let us have one more variable, that is star I, a pointer variable. One more I have taken, and simply I will use a for loop, and then I have to go for the one by one from one block to the another block. I need to travel. Why I need to travel, you will just come to know. So over here I will say I is equal to start, now which means I is also going to point to the same memory block, and then I will say I of address if it is not equal to null, and then I will increment the pointer, that is this way. Okay, and then there is no block for this, so simply I will give a semicolon. Now you can achieve this using a while loop also. Just initialize this before the while loop, and then increment this inside the while loop, and this will be the condition of the while loop. When I say semicolon, this will just execute, it will just go through the blocks. Now what does this mean is, now we are over here, isn't it? So we will be assigning one more block. So let us just assign one more block, or what we can do is we can do it after this also. So what is this going to do is I is equal to start. So I is going to point to this particular memory location. Okay, address will is null. So if I say that is I of address not equal to null, but it is null, so I will be pointing to the same block, and the loop will get terminated for the second time. I'm talking about the second time, please understand this. And then what I'm going to do is I'm going to say temp is equal to the same code that we require over here, that's over here. I'll copy this and paste it over here. Now when we go for the third one, fourth one, you will slowly understand why we need to do this. Okay, then again I'm going to allocate a memory block, take the data, assign the null to the address part, and then what I need to do over here, this is going to create one more memory block, that is this one. And now we need to connect these two blocks. How are we going to connect these two blocks? Is simply we need to store the address of this block into the address part of the first block, that is the start or the I and start both are pointing to this block, please understand this. So how I'm going to achieve that is I'm going to say I of address, and I'm going to store the address of temp. And what is temp? This is the second block, so maybe it is 2457. This will get stored over here, this will get stored over here. Okay, now what will happen is, so everything is working fine. Now again, if the user says he gives the choice as 1, and that coding we need to do, again I will say print f, and the message will be, do you want to continue? Okay, and we'll just simply say yes or 0. So 1 will present yes, 0 will present no. You can give y and n also, no issues. And then semicolon, I will scan this into %d, comma, that is choice. So if choice is 1, again this loop is going to run, and then this if condition is going to go false, and again it will come to the else part. Now what is going to happen is, we are going to create a third block. Now let us understand how this loop is going to work. This loop, I will point to start, which means this particular block, and then what I'm saying over here is I of address not equal to null. Now if you see the first block, the address part, now it is not null. If it is not null, what is going to happen? I is going to get incremented, and how it is going to get incremented? That is I is equal to I of address. Now what is I of address? That is the address part is 1026, and that again we are giving it to I. So what address? See over here, that's okay. So this is the address of the second block, that is 2457, isn't it? So this address, again it is going to get to I. So I will be now pointing to the next block, and the next block, the address part will be null, and then it will terminate, and then again we are assigning a third block and giving that address, storing the address of the third block into the address part of I, and I is pointing to the second block. Please understand this. Okay, and again this will run, so everything looks fine. And then if the user gives no, if he gives any other value than 1, then simply we will display. So simply we require this loop again over here, but this time it won't be semicolon. Over here simply we'll print the data, that is %d, that is %d, and then I, the data part, that's it. Okay, now please understand, we actually need to come up with functions, and every function will do a small part for us. Okay, now this is just an initial part, so I'm just typing it everything into the main function. In the next tutorial we are going to organize this code in a much professional manner. Okay, so right now let us just run this code and see if it works or not. If there are any errors, we will rectify it. So let me just run this, and there is a error, that is for the scanf, that is over here. I don't have the semicolon, no issues. Then again we will run, again it says there is some error, that is over here, that is there is no semicolon over here. Okay, again I will try to run this, and there is an error over here, that is print f. Okay, let us try to run again, and hopefully it should run, and it has run for us. Now it is asking for a number. Now if there is any error, any logical error, we will get rid of it. Since we are doing this live, definitely there will be certain errors that will come up, and that is how we learn. We come up with errors, we rectify it, and that is why I am doing this live. So I'll give the value 12. Okay, and then I will give the value 1, since I want to continue this. And again it is asking me 45, again 1, 7, 1, 9, and now I'll give 0, and let us see the output. Now the output is 12, 45, 67, but the last number it has not shown, and these numbers are all together. So how I'm going to rectify this is, I'm going to give a /n, and it has not shown me the last data. Why it has not shown me the last data is because I'm saying I of address not equal to null. For example, we have created so many blocks, okay, so many nodes, so it will print this is not null, I of address is not null, I of address is not null, so it will print this also, this also, this also, but at the last this will always be null. So this will not print the last address. So what I need to do over here is I will simply say if I not equal to null straight away. Why? Because when I say I will come over here, and then when I will increment, so it will get the address part, and the address part will be null, so I will get null, and so it will print the last value also. So let us just run this and run see the output. Okay, everything is working fine. 12, I will say 1 45 1 1 1 90, and now 0, and here is the output, that is 12 45 67 and 90. So we have a perfect output. So this is how to develop a singly linked list, and now we are going to have a lot of operations that we are going to perform, and in the next video I'm going to organize this particular code in functions, so that is a more professional way to do it, and then we'll perform some more operations onto this. Okay, so that's it for today, and this particular code I'm going to give it to you in the description box, so you can just have this code, study it. Okay, so that's it for today. Bye for now.